Alright, question 1. I can't narrate every internal step, but here's the concise reasoning. The passage sets up a contrast. While enemy leaders are labeled mad, the very traits associated with madness can be assets for effective leaders, and may even be common among great ones. That undercuts the idea that mad is a fair description. It then lands on its real point in the final sentence. The label mad is used cynically to dehumanize and discredit opponents. That's the author's main conclusion. The earlier material functions as supporting reasons. So the best match is that mad is a propaganda tool rather than a genuine description. Option E. Alright, question 2. We've a little cafe that makes 50 mini pizzas and 50 flapjacks. Morning prices. Pizzas, $2. Flapjacks, $1. By lunchtime, 10 pizzas and 15 flapjacks remain, so prices are halved for the afternoon. At close, 2 pizzas and 1 flapjack are still left and given away. I'll do this chronologically. It keeps errors at bay. Morning sales first. If 10 pizzas are left at lunch, that means 40 sold at full price. 40 times $2 equals $80. For flapjacks, 15 left at lunch means 35 sold at $1. 35 times $1 equals $35. Afternoon, the prices are halved. Pizzas at $1, flapjacks at 50 cents. From the 10 pizzas left, 2 still remain at the end, so 8 are actually sold in the afternoon. 8 times $1 equals $8. For flapjacks, from the 15 left at lunch, 1 remains at the end, so 14 sold at half price. 14 times 50 cents equals $7. Now total revenue. Pizzas $80 plus $8 equals $88. Flapjacks $35 plus $7 equals $42. Together, that's $88 plus $42 equals $130. Production cost for the whole batch, both items, is $30. Profit is revenue minus total cost, even though a few were given away. $130 minus $30 equals $100. So option A. The quick check is, full price revenue would have been $150 if all sold in the morning. The markdowns and giveaways reduce that by $20 on pizzas, 10 discounted by $1 each, plus 2 given free at $1 equivalent, and by $10 on flapjacks, 15 discounted by 50 cents each, plus 1 given free at 50 cents. Total reduction $30, giving $120 revenue. I nearly tripped there, but that logic double counts the discount. Safer to stick with the step-by-step totals we did. $130 revenue, $30 cost. Profit, $100. Final answer, A. Alright, question 3. We're told turnout is falling mainly because younger people vote less, older people vote more. And if that continues, we'll end up with governments lacking a mandate. So, we must find an alternative to elections. The key is to spot the unstated assumption that makes that leap plausible. The argument treats the current behavior of the young as if it will remain the behavior of those same people for life. But in most electorates, voting is strongly age-related. People tend to vote more as they get older. If that's the case, today's low participation cohort may not remain low participation once they become middle-aged and older. So, the projected collapse in turnout and the dramatic conclusion that elections must be replaced doesn't necessarily follow. Option E states exactly this. People who are young now may become more likely to vote as they get older. That undercuts the argument's prediction and therefore its urgency to replace elections. By contrast, A worries about practical issues with alternatives. That doesn't show the original inference is flawed. B talks about pressure groups. Interesting, but not a logical refutation of the claim about mandates. C and D are generic facts about countries and practices. They don't address the reasoning error. So, the flaw is an unwarranted extrapolation. Assuming a trend persists across time without allowing for age effects. The best answer is E. Alright, Question 4. We've a short argument about celebrities and their influence on young people via the ever-present media. The passage sets up two types of celebrity behavior, some admirable, charitable, resisting pressures, and some undesirable, glamorizing drinking, smoking, swearing, promiscuity. The key move comes at the end. Despite many celebrities claiming they don't wish to be role models, the author says that's unrealistic and irresponsible because their behavior will be imitated. So, what's the conclusion we can draw? We're looking for something that captures that final thrust. Celebrities do function as role models, whether they intend to or not, and therefore bear responsibility for their conduct. Let's test the options. A. We are living in an age of celebrity culture. That's scene setting, but not the conclusion. C. Less media coverage would stop young people imitating their role models. That's a speculative policy claim, not argued for. D. Parents should monitor what their children are exposed to. Sensible, but not in the passage. E. Celebrities should not be regarded as role models. That's the opposite of what the author says. B says, celebrities should act responsibly because they are role models whether they like it or not. That neatly mirrors the final sentence. Their behavior will be imitated. So claiming not to be a role model is unrealistic and irresponsible, hence, act responsibly. That's the author's conclusion, drawn from the premises about influence and imitation. So the best supported conclusion is B. All right, question 5. We've got an argument railing against nepotism, bosses appointing their sons. The author says this is unfair to other, perhaps more talented and experienced workers, and since it's highly unlikely the son is actually the best candidate, favoring family should be made illegal. Now, what must they be assuming for that move to work? The key steps are, 1. It's unfair because the son probably isn't the best, and 2. Therefore, make it illegal. I'm looking for a principal, silently doing the heavy lifting. Let's scan the options. A. Talent runs in families. That would actually weaken the case. If anything, it would make the son more plausible, so not an assumption. C. It's recognized as corrupt. The author isn't appealing to recognition. They want it to be illegal, so current recognition is irrelevant. D. No substitute for experience. Too specific. They do mention talent and experience, but they don't claim experience is the only route, so that's not required. E. Owners should be free. Flatly contrary to the conclusion. That leaves B. The best candidate should always be appointed. Now, do we need the always? The conclusion is, make nepotism illegal across the board. To justify illegality because the son is unlikely to be the best, you're assuming the rule that appointments should be made on merit. The best candidate should get the job. If you deny that, say it's fine to appoint someone not the best for other reasons, the argument for a blanket ban collapses. So yes, the unstated principle is meritocracy as a strict norm. That bridges unfair to should be illegal. So the underlying assumption is B.
Isn't he great? Arthur's your very own Oxbridge tutor, built by real tutors who've guided hundreds of applicants into Oxford and Cambridge. He doesn't just know what makes a good candidate. He knows what makes an exceptional one. You've already learned from him here. Imagine what happens when he's guiding you directly. Interview slots fill quickly before the season starts, so don't wait. Book your session now at arthurtutoring.co.uk.
All right, question 6. We've a picture that's 40 centimeters high and 30 centimeters wide. Around it sits a mount, 6 centimeters at the top and sides, but a deeper 9 centimeters at the bottom. Outside that, a wooden frame whose width is 2 centimeters. We're asked for the overall height of the framed picture, so from the very top edge of the wood to the very bottom edge. No diagram, but the structure is picture, then mount, then frame. For height, only the top and bottom matter. Start with the picture's 40 centimeters. Add the mount, 6 centimeters on top, 9 centimeters on the bottom. So that's plus 15, taking us to 55 centimeters. Now the frame. The 2 centimeter wood sits outside the mount, so it increases the outside height by 2 at the top and 2 at the bottom, plus 4 altogether. That gives 55 plus 4 equals 59 centimeters. Quick sense check against the options. 46 and 49 would ignore either the bottom-heavy mount or the frame entirely. Too small. 56 would be forgetting one side of the frame. 62 would be overcounting something. So 59 is the neat fit. Therefore, the overall height of the framed picture is 59 centimeters. That's option D. All right, question 7. We've a little table of monthly car sales for 2012 and 2013, and we're asked, in 2013, which month saw the biggest increase compared with the previous month? Looking at this table, I'll ignore the 2012 row completely. It's a decoy. We only need the 2013 sequence: 123, 106, 87, 114, 90, 106, 124, 113, 131, 77, 92, 75. Now, month-on-month changes. I'll do quick differences. Feb minus Jan, 106 minus 123 equals negative 17, so down. Mar minus Feb, 87 minus 106 equals negative 19, down again. April minus March, 114 minus 87 equals plus 27. That's a healthy jump, candidate for the biggest. May minus April, 90 minus 114 equals negative 24, down. June minus May, 106 minus 90 equals plus 16, up. July minus June, 124 minus 106 equals plus 18, up. August minus July, 113 minus 124 equals negative 11, down. September minus August, 131 minus 113 equals plus 18, up. October minus September, 77 minus 131 equals negative 54, big drop. November minus October, 92 minus 77 equals plus 15, up. December minus November, 75 minus 92 equals negative 17, down. I initially glanced at September because 131 is the highest monthly total, tempting to think that must be the biggest rise. But we're not after the highest number, we're after the largest increase. September's increase is plus 18 from August. April's increase is plus 27 from March, which is larger. Checking the options, April is there. June plus 16, July plus 18, September plus 18, November plus 15. The standout is April with plus 27. So the month with the biggest increase is April. Answer A. All right. Question 8. Rosie's mowing a rectangular lawn, and we're given all the numbers in the text. The lawn is 10 meters by 25 meters, and there's a 2 meter by 3 meter patio in one corner she doesn't mow. The key rates are 2 square meters per minute with the new mower and 1 square meter per minute with the old one. First, calculate the mowable area. The whole lawn is 10 times 25, which equals 250 square meters. Subtract the patio. 2 times 3 equals 6 square meters. So the grass to mow is 250 minus 6 equals 244 square meters. Time is area divided by rate. With the old mower at 1 square meter per minute, it would take 244 minutes. With the new mower at 2 square meters per minute, it takes 244 divided by 2, which equals 122 minutes. So the time saved is 244 minus 122, which equals 122 minutes. That matches option A. Quick check. Having the time makes sense because the new mower doubles the rate. Final answer, A, 122 minutes saved. The original argument infers that because 11% of customers are still with the bank their parents set them up with, people must generally be satisfied with their banks. That inference depends on an unstated assumption that remaining with the same bank indicates satisfaction rather than other causes, inertia, lack of need to switch, habit, ignorance, etc. Option A states that nearly 2/3 of UK bank customers have changed banks, and 2% have switched more than 5 times. This directly undermines the argument in 2 ways. It shows that the 11% figure is a small minority, not a representative majority. If most people do switch banks at some point, the mere fact that 11% have stayed with their childhood bank is weak evidence about general satisfaction. The fact that many customers have switched, some repeatedly, suggests active mobility and dissatisfaction, or at least willingness to leave, offering an alternative explanation for why only a minority remain with their childhood bank. That alternative explanation defeats the argument's key assumption that staying equals satisfaction. Therefore, A most effectively weakens the claim that the 11% figure strongly suggests overall contentment with banking services. All right, question 10. We've got a government push for pupils to learn and recite poetry, intended to boost confidence and increase awareness. The claim then jumps to, by taking part and reciting, young people will improve their appreciation of poetry. The key issue is a shift in terms. The premises talk about awareness and confidence, but the conclusion asserts appreciation. Awareness is not the same as appreciation. Noticing poetry exists or hearing it more isn't identical to valuing or understanding it more deeply. Option C names that shift precisely. Option B says you don't have to recite to appreciate. That's a point about necessity, which doesn't undermine the claim that reciting could improve appreciation. Option E brings in creativity, which isn't at issue. A and D challenge background assumptions about current awareness or confidence, but they don't nail the logical leap from awareness to appreciation. So the flaw is the conflation of awareness with appreciation. Answer C. All right, question 11. We're given a rosy claim. Booming health clubs must mean society values healthy bodies for healthy minds. The passage immediately pushes back. That claim is mistaken, and then piles on reasons. People deceive themselves. Marketing sways them. Many pay and hardly go, and one can jog for free rather than on a treadmill. So the upshot isn't that health clubs are wicked per se, nor that no one gets fit, but that using health club success as evidence for improving public health is unreliable. The author's central move is to reject the inference from more memberships to better health, based on self-deception and underuse. Options that talk about deception or lack of health are supporting ideas, not the main conclusion. The only choice that captures the author's top-line claim, that claim is mistaken. Is that the success of health clubs isn't a trustworthy sign of health improvement? That's option D. So I'll go with D. The boom in health clubs does not reliably indicate a healthier populace. The rest is scaffolding to justify that. All right, question 12. We've got 7 crisp coupons, each either 19p, 12p, or 7p. He has at least one of each, and together they make exactly £1, so 100 pence. We're asked, how many are 19p? No diagram to stare at, just those 3 values. Let's set it up neatly. Let X be the number of 19p coupons, Y the 12p ones, and Z the 7p ones. We know 2 things. X plus Y plus Z equals 7. 19X plus 12Y plus 7Z equals 100. I'll use the first to eliminate Z. Z equals 7 minus X minus Y. Substitute into the money equation, 19x plus 12y plus 7 minus y equals 100. That simplifies to 19x minus 7x plus 12y minus 7y plus 49 equals 100. So 12x plus 5y plus 49 equals 100. Hence, 12x plus 5y equals 51. That's a nice little Diophantine equation. Let's look mod 5. 12x equals 51 mod 5. Since 12 equals 2 and 51 equals 1, we have 2x equals 1 mod 5. So x equals 3 mod 5. So x could be 3, 8, 13, but we only have 7 coupons total, so x can't be 8 or more. That leaves x equals 3. Check it gives integer y. 12 times 3 equals 36. 51 minus 36 equals 15. So 5y equals 15, y equals 3. Then z equals 7 minus 3 equals 1. We've got at least one of each. Tick. And the total is 3 times 19 plus 3 times 12 plus 1 times 7 equals 57 plus 36 plus 7 equals 100. Perfect. So the number of 19p coupons is 3. That's option C. Alright, question 13. We're asked which team scored at least one goal in every match last season. The table shows every home score, first number in a cell, and every away score, second number. The efficient approach is simple and robust. For each candidate team, I checked both their row, home matches, and their column, away matches, for any match where they scored 0. 1-0 means they fail the condition. I won't narrate every tiny arithmetic move, but here are the key checkpoints. Amazon's away match at Nile contains a 2-0, so Amazon failed. Ganges were beaten 2-0 away at Yangtze, so out. Nile were held scoreless away at Tigris in one fixture, so out. Volga failed to score away at Nile in one game, so out. Rhine, by contrast, has no match in its home row with a 0, and no away fixture where Rhine's own goal total is 0. Every Rhine score in the table is at least 1. That makes Rhine the only team to have scored in every match. Final answer, Rhine. A is correct. Reasoning, visual, constructive argument. The grayed area is exactly the shape of one full tile from the pattern. That full tile outline can be obtained by assembling 3 of the odd pieces without ever turning any piece face down. Pieces 1, 2, and 5 interlock to reproduce the full tile outline and fill the area exactly. How to see this concretely? 1. Look at the missing tile's outline and the little tabs and notches on the available pieces. Piece 5 provides the tall vertical step that matches the pillar side edge of the missing tile when rotated as shown in the diagram. No flipping. Its long vertical tab matches the pillar edge step of the gray shape. 2. Piece 2 supplies a small horizontal tab that fits into the left part of the missing tile's profile. When placed adjacent to piece 5, it continues the outline without leaving gaps or overlaps. 3. Piece 1 fills the remaining central notch. It has complementary concave and convex parts that mate with the exposed edges of pieces 2 and 5, closing the outline and completing the full tile. Area and edge matching checks. The combined area of pieces 1, 2, and 5 equals the area of the missing tile. Each piece is a cut from the same tile grid, and there are no leftover small units. All adjoining edges are complementary. Every outward tab meets an inward notch, so the 3 pieces fit flush. Because none of the pieces need to be turned face down, and rotations only are allowed, the orientation of the pattern remains consistent. Why the other options fail, briefly? Any set that does not include the tall vertical step, which only piece 5 supplies, cannot reproduce the pillar side profile. Thus, sets without piece 5 cannot match the missing tile's outline. Combinations that include piece 5 plus 2 others that do not have the correctly shaped complementary tabs will either leave a gap or create an overlap. For example, replacing piece 2 or 1 by piece 3 or 4 leaves unmatched protrusions or concavities that cannot be resolved without flipping a piece. Therefore, pieces 1, 2, and 5 are the only trio that assemble in the given face-up orientation to fill the missing corner exactly. Hence, A is the correct choice. Alright, question 15. The passage lays out a classic environmental trade-off. Single-use plastic bags are problematic, both in how they're made, wasteful use of resources, and how they're disposed of, litter, marine harm. Some jurisdictions have banned them, yet experts warn that alternatives aren't spotless either. Make a bag stronger so it can be reused, and you inevitably spend more resources up front. So the message isn't, this bag good, that bag bad. It's look at the whole picture. That whole picture includes at least 3 things. First, manufacturing. What resources and energy go in at the start? Second, length of use. Does the bag get reused enough times to pay back its higher production cost? Third, end of life. Do we recycle, landfill, or, worst of all, litter it into ecosystems? The passage explicitly gestures at all 3. The distractors overreach. Broad claims about behavior change or blanket bans aren't supported. Population growth and use paper instead aren't even discussed. The justified takeaway is the general principle of life cycle thinking. Hence, the conclusion we can draw is E.
Isn't he great? Arthur's your very own Oxbridge tutor, built by real tutors who've guided hundreds of applicants into Oxford and Cambridge. He doesn't just know what makes a good candidate. He knows what makes an exceptional one. You've already learned from him here. Imagine what happens when he's guiding you directly. Interview slots fill quickly before the season starts, so don't wait. Book your session now at arthurtutoring.co.uk.
All right, question 16. We're told some cities waive or discount congestion charges for low-emission vehicles. The author calls that illogical and unfair because emissions don't affect congestion and low-emission cars still clog the roads. Plus, people who can't afford cleaner cars must still pay even while congestion persists. For that to work as an argument, the writer must be taking for granted that the congestion charge is about congestion, not about emissions. If the scheme had a dual purpose, reducing both congestion and pollution, then giving cleaner cars a discount could be perfectly logical. So the hidden plank is, the principal purpose of a congestion charge is to reduce congestion. That's option A. Why not the others? B says it's not important to reduce emissions. Much stronger than needed. The passage doesn't claim that. C claims all drivers would buy low-emission cars if they could. Irrelevant to the logic. D says congestion charging hasn't helped anywhere. That's not at issue. E imagines a world where everyone drives low-emission cars and nobody pays. Again, not required for the author's point. So the necessary assumption is A. The charge's purpose is congestion reduction, making emissions-based discounts illogical in the author's framing. Final answer, A. Because the argument presupposes congestion, not emissions, is the target of the policy. All right, question 17. The passage's core claim is that digital technology makes information flow fast and decentralized, so classic gatekeeping and censorship no longer work well. Falsehoods are also hard to scrub. From that, it concludes governments and traditional media must adapt. So, the best strengthening fact will be one that shows why control and correction are harder in the new environment. Option C. Information can be posted anonymously. Avoiding prosecution directly heightens the difficulty of controlling, deterring, or removing content. If you can't reliably identify the poster, traditional levers of control lose bite. That pushes precisely toward they must find new ways. Briefly on the rest. A. Actually undercuts the claim by showing censorship still works in some places. B is about journalists using phones. irrelevant to the argument about mass participation and control. D. Suggests existing legal remedies are functioning. That weakens the can't-be-removed difficulty. E. Is historical context that doesn't increase today's challenge. If anything, it shows prior reliance on gatekeepers. So C most cleanly reinforces the argument's thrust. Anonymity makes old mechanisms ineffective, hence the need to adapt. Final answer, C, because anonymity amplifies the very challenges the passage describes. All right, question 18. We're painting a rectangular dining room, length 8 meters, width 4 meters, height 3 meters. We need to paint all 4 walls and the ceiling, but not the door and 3 windows, whose combined area is 10 square meters. Paint comes in 8-liter tins, and each liter covers 12 square meters. First, the surface to paint. A neat shortcut for the walls. Instead of doing 4 rectangles one by one, take the perimeter of the floor and multiply by the height. The perimeter is 2 times 8 plus 4 equals 24 meters. Times the height 3 gives 72 square meters for all the walls together. Ceiling next. That's just the floor area. 8 times 4 equals 32 square meters. Add them. 72 plus 32 equals 104 square meters. We're told not to paint the door and windows, 10 square meters, so subtract. 104 minus 10 equals 94 square meters to paint. Coverage. 1 liter does 12 square meters, so an 8-liter tin covers 8 times 12 equals 96 square meters. That's the little aha. 1 tin covers 96, which is just more than our 94 requirement. We don't need to round up to 2 tins. 1 tin suffices. So the answer is A, 1 tin. Quick, tidy, and we've avoided counting the floor or double counting any wall. All right, question 19. We're given the heptathlon high jump scoring table and told Daphne has just beaten her previous best by 18 centimeters, which raised her point score by 214. We need her new personal best height. Looking at this table, the sensible way is to recognize that an 18-centimeter improvement is 0.18 meters, so we should seek 2 rows whose performances differ by 0.18 and whose points differ by 214. I'll scan the likely candidate answers rather than every row, a useful time saver in an exam. First thought, option A, 1.09 meters, would imply her previous best was 0.91 meters. 1.09 minus 0.18. It doesn't even go that low, so A is impossible. That's a quick elimination. Next, I glance at B, 1.44 meters. If 1.44 were the new best, the old would be 1.26 meters. Looking at the table, I see 1.44 corresponds to about 555 points, and 1.26 to about 369. Subtracting gives 555 minus 369, that's 186, not 214, so B fails. Now C, 1.74 meters. The previous would be 1.56 meters. I check the table. 1.74 is listed as 903 points, and 1.56 as 689. Subtracting 903 minus 689 gives exactly 214. That's a perfect match to the given increase, so C fits neatly. For completeness, D, 1.89, and E, 2.09, are much higher. I'd expect their 0.18 lower partners to give different point gaps, and since C already matches exactly, there's no need to chase those. The neat match at 1.74, 1.56 is convincing. So final answer, 1.74 meters. Because the table shows 1.74 equals 903 points, and 1.56 equals 689 points. Difference 214, an 18-centimeter improvement. We are asked for the monthly differences 2007 minus 2012, and which chart matches that pattern. Compute the differences 2007 minus 2012 for each month. Jan, 161.2 minus 124.1 is 37.1. Feb. 71.5 minus 61.4 is 10.1. Mar. 445.3 minus 367.9 is 77.4. April. 167.9 minus 138.0 is 29.9. May. 184.8 minus 159.0 is 25.8. June. 220.6 minus 185.5 is 35.1. July. 175.3 minus 141.7 is 33.6. August. 76.2 minus 57.5 is 18.7. September. 419.1 minus 359.0 is 60.1. October. 168.0 minus 149.7 is 18.3. November. 160.5 minus 150.3 is 10.2. December. 139.8 minus 123.1 is 16.7. Key features of the true differences. March is the largest difference, approximately 77.4. September is the second largest, approximately 60.1. January, June, and July are the next largest, around 33 to 37. April and May are moderately large, approximately 26 to 30. August, October, December are smaller, approximately 17 to 19. February and November are the smallest, approximately 10 each. Option D is the chart whose bar heights follow that exact pattern. A very tall bar in March, the next tallest in September, mid-height bars for Jan, June, July, slightly lower bars for April, May, small bars for Aug, October, December, and the two smallest bars for Feb and November. The other options either swap the order of March and September or show incorrect relative heights for several months, so they do not match the computed differences. Therefore, D is the correct chart. All right, question 21. The passage argues that because some unlicensed moneylenders charge excessive interest and many use threats, therefore anyone convicted of lending without a license should go to prison. The leap is from evidence about some unlicensed lenders' bad behavior to a blanket punishment for all who commit the offense. That's a classic overgeneralization. The premises don't show that every unlicensed lender is exploitative or violent, only that some are. The reference to poor and vulnerable adds emotive color, but it isn't the core logical flaw driving the conclusion. Nor does the argument hinge on what licensed lenders do. The best description of the flaw is that it draws a conclusion about all unlicensed moneylenders on the basis of evidence about some of them. So I'm choosing B. All right. Question 22. We've got a classic either-or setup. Either the kids are getting cleverer or the exams are getting easier. Then the argument says there's very little evidence that kids are actually more intelligent, so we must conclude the exams are easier. Structurally, that's disjunctive syllogism. Either P or Q, not P, therefore Q. I'm looking for an option that mirrors that exact skeleton. Two exhaustive categories, rule one out, infer the other. Option A. Farmers choosing organic or non-organic, then a discussion about yields and difficulty changing, and a recommendation to consider long-term impacts. That's not eliminating one and concluding the other. It's advisory, not deductive. Out. Option B. Holidays in the UK or abroad. People like predictable weather, so most we go abroad. That's more of a causal explanation or a probabilistic inference, not a strict either-or with elimination. Not parallel. Option C. Meerkat calls fall into two categories, greetings or alarms. Since this one isn't a greeting, it must be an alarm. That's bang on. Exactly either P or Q, not P, hence Q. The content even uses a clean dichotomy. Option D. Stoves better than open fires. They're more efficient, therefore more people should install them. That's an evaluative argument leading to a recommendation. No disjunction eliminated. Option E, prioritizing children and the elderly. So if you're neither, you may wait longer. That's conditional prioritization, not an either-or structure. So C is the closest parallel by a country mile. The meerkat reasoning is structurally identical. My final answer is C, because it employs the same disjunctive syllogism. Two categories. Rule one out, conclude the other. All right, question 23. The author's line is classic anti-paternalism. People accept risks, and it's their responsibility. The state shouldn't interfere merely to stop individuals from harming themselves. Hence, making helmets compulsory is framed as undue government interference in personal choice. So, we're looking for an option that applies that same principle. The government should not be in the business of restricting self-regarding behavior, even if it's risky. Among the options, legalizing recreational drugs best mirrors that stance. It says, in effect, let adults make their own choices about potentially harmful activities without state intrusion. The others sit elsewhere. The funding argument about alcoholics is a resource allocation claim, not about liberty. Promoting helmets is persuasion, not law. Combating cyberbullying and fining parents both endorse more state intervention to control behavior. Indeed, the opposite spirit to the passage. So the option that illustrates the principle used, personal responsibility over state paternalism, is B. That's the match. Final answer B, because it embodies the anti-paternalist principle of limiting government interference in self-regarding choices. All right, question 24. We've got a 6.0 kilogram mixture of two chemicals, X and Y. The text says it's 1/4 X and 3/4 Y. So 25% X, 75% Y. No diagram here, just the proportions in the prompt. That means, of the 6.0 kilogram, X is 1.5 kilogram, and Y is 4.5 kilograms. The technician now adds only more X until the overall mixture is 40% X and 60% Y. Let X be the kilograms of X added. Then X becomes 1.5 plus X. Total mass becomes 6 plus X. And we want 1.5 plus X divided by 6 plus X equals 0.4. Solve quickly. 1.5 plus X equals 0.4 times 6 plus X equals 2.4 plus 0.4X. Subtract 0.4X from both sides. 0.6X equals 0.9. So X equals 1.5 kilograms. Quick sanity check. Adding 1.5 kilograms of X gives 3.0 kilograms of X out of 7.5 kilograms total, which is indeed 40%. So the required addition is 1.5 kilograms of X. Answer B. All right, question 25. 5 friends rank choices for holiday destinations and a scoring scheme. 3 points for first, 2 for second, 1 for third. Crucial constraint. They won't go anywhere that isn't someone's first choice. So I'm on the lookout for that trap. France looks popular as a second, but if no one has it first, it's out. Let me map the preferences quickly. First choices: Joe, Portugal; Mel, Portugal; Kim, Mallorca; Lexi, Greece; Naz, Tenerife. Seconds: Joe, France; Mel, France; Kim, France; Lexi, Tenerife; Naz, France. Thirds: Joe, Greece; Mel, Tenerife; Kim, Tenerife; Lexi, France; Naz, Mallorca. Now, tally only among places that appear as a first choice: Portugal, Mallorca, Greece, Tenerife. I'll still note France is disqualified by the rule. Portugal, 2 firsts from Joe and Mel gets 3 plus 3 equals 6 points. No seconds or thirds for Portugal mentioned, so it stays at 6. Mallorca, Kim's first gives 3. Naz's third adds 1. Total 4. Greece. Lexi's first gives 3. Joe's third adds 1, total 4. Tenerife. Naz's first gives 3. Lexi's second adds 2. Mel and Kim each give a third, so +1 + 1. That's 3 + 2 + 2 equals 7. France, for completeness, would score well from seconds and thirds, but it's not a first choice for anyone, so it's ruled out by their agreement. Comparing the eligible totals, Portugal 6, Majorca 4, Greece 4, Tenerife 7. Highest is Tenerife, so they went to Tenerife. Final answer, E, because it has the greatest weighted score among destinations with at least one first-choice vote. Alright, question 26. We have a net of a cube, and some of the faces have one diagonal drawn on them. The question, when the net is folded, at how many of the cube's 8 corners do exactly 2 of those face diagonals meet? Looking at the net, there are 6 squares, the 6 faces. I can see a diagonal drawn on 5 of them. One face is left plain. A handy counting trick is to think about diagonal endpoints. Each diagonal contributes 2 endpoints, so 5 diagonals give 10 endpoints in total. And these endpoints sit on the cube's 8 vertices. At any cube vertex, between 0 and 3 of those diagonals can meet, because 3 faces meet at a vertex. My first impression is to hunt for obvious vertices where 3 diagonals meet. Those reduce the remaining endpoints. Inspecting the net carefully, there is a corner in the net where 3 diagonals meet at the same net point. This becomes a single cube vertex when folded. Symmetry of the net gives another opposite vertex with 3 diagonals meeting there as well. So we have 2 vertices with 3 endpoints each, consuming 6 of the 10 endpoints. That leaves 4 endpoints to be distributed among the remaining 6 vertices. If none of those remaining vertices ends up with 3, the simplest distribution is that exactly 4 of them have 1 endpoint each, and the remaining 2 have none. But the question asks for vertices with exactly 2 diagonals. To get some vertices with exactly 2, we need to pair those leftover endpoints 2 and 2. The net's geometry forces those leftover endpoints to fall as pairs at 2 distinct vertices. In other words, 2 vertices each receive 2 endpoints, exactly 2 diagonals, and the other 4 vertices have 0. So the net produces exactly 2 vertices where 2 face diagonals meet. I briefly suspected more such vertices, but the endpoint arithmetic and the observed pair of triple meet vertices rules that out. So the answer is C. 4 would have been tempting if you miscounted how many triple meet vertices there are. But careful folding and the endpoint sum show the correct count of corners with exactly 2 diagonals is 4. Alright, question 27. The passage opens with a clear policy claim. The HRA should apply to soldiers in the UK and at their bases overseas, but not when they're in the heat of battle. What follows are the reasons: concern about damaging effectiveness, and commanders being paralyzed by fear of legal actions when making split-second decisions. That structure signals the first sentence as the main conclusion, with the rest as supporting premises. Option A precisely restates that policy position. Options B, D, and E are reasons offered to support the conclusion, not the conclusion itself. And C contradicts the passage's stance by ruling out the HRA entirely for the armed forces. So the main conclusion is that the HRA should apply away from battle, but not in it. Option A. Alright, question 28. We're told that demand for fish is soaring while most marine stocks are already overfished. Aquaculture is floated as a possible solution, but with 2 caveats. Environmental risks like pollution and disease must be controlled, and crucially, current methods for farming certain predators, like tuna, still rely on wild-caught fish, which adds pressure to the oceans. Now, to the options. A suggests switching to freshwater fish. Nothing in the passage contrasts marine with freshwater aquaculture, so that's an unsupported leap. B says nothing can be done to make ocean fishing less damaging. Our passage doesn't address reforming ocean fishing at all, so we can't conclude that. C goes all the way to vegetarianism across all fish and meat, far beyond what's stated. Between D and E claims only some kinds of fish farming are likely to cause environmental damage. The passage says aquaculture in general carries environmental risks requiring controls. That doesn't justify only some, nor likely for some and not others. By contrast, D fits the logic given. At present, farming predator species like tuna requires feeding them wild-caught fish, which directly contributes to ocean pressure. If aquaculture is being proposed to reduce pressure, then attempting to farm those predators now would undercut that aim. So the conclusion we can draw is that fish farms should currently avoid rearing predator fish until methods that don't rely on wild-caught feed exist. So D is the best supported conclusion. All right, question 29. We're told a study found that drinking hot chocolate for a month boosted cerebral blood flow and improved memory scores. And from this, the claim is floated that a daily dose could help prevent Alzheimer's and keep the brain healthy. To justify that leap, we need a bridge from short-term improvements in general brain functioning to reduced risk of Alzheimer's. The crucial assumption is that problems with general brain functioning, such as poorer blood flow or memory, are meaningfully linked to the development of Alzheimer's. If that link doesn't hold, then a month's worth of better recall times tells us little about preventing a neurodegenerative disease. The other options don't underwrite the argument. Whether eating chocolate works is irrelevant to a claim about drinking hot chocolate. Concerns about sample size or other health risks challenge the study but aren't required for the conclusion. And permanence isn't necessary if the claim is about regular consumption helping to maintain brain health. The necessary hidden premise is that improving general brain function relates to preventing Alzheimer's, option E. So I'll choose E because it provides the needed causal connection the argument relies on. All right, question 30. Two scoring types. A major is 5 points, a minor is 3. The final scores were Reds 77, Blues 52. The Blues had exactly twice as many majors as minors, and the Reds had exactly half as many majors as minors. That is, the Reds' majors are half their minors. I like to turn those phrases into ratios. For the Blues, twice as many majors as minors means majors-minors equals 2 to 1. Think in packets. Each packet of 2 majors and 1 minor is worth 2 times 5 plus 1 times 3 equals 13 points. Blues scored 52, which is 52 divided by 13 equals 4 packets. So Blues had 4 minors and 8 majors. For the Reds, half as many majors as minors means majors-minors equals 1, 2. 1 packet there is 1 major and 2 minors, worth 5 plus 2 times 3 equals 11 points. Reds scored 77, and 77 divided by 11 equals 7 packets. So Reds had 7 majors and 14 minors. We're asked for the total majors in the match. 8 from the Blues plus 7 from the Reds gives 15. Quick check. 8 times 5 plus 4 times 3 equals 52. 7 times 5 plus 14 times 3 equals 77. All consistent. So the answer is 15, option C. All right, question 31. We've got a 300-gram packet of oatcakes. The label gives 2 kinds of figures, per oatcake and typical values per 100 grams. We're asked, how many oatcakes are in the packet? Looking at this table, each oatcake has 53 calories, 2.2 grams of fat, 0.6 grams saturates, 0.2 grams salt, 0.3 grams sugars, and per 100 grams, the product has 427 calories, 17.6 grams fat, 5.0 grams saturates, 1.4 grams salt, 2.4 grams sugars. Strategy: find the mass of one oatcake by matching a per cake figure to the per 100 gram figure. Then divide 300 grams by that mass. My first lazy instinct is to use salt, 0.2 grams per cake versus 1.4 grams per 100 grams. That would suggest a cake mass of 0.2 over 1.4 times 100, slightly 14.3 grams, which would give about 21 cakes. Tempting. Option C is right there. But hold on. The per cake numbers are rounded to the nearest 0.1 gram. Salt is tiny. Rounding error is huge here. Better to use a big, stable quantity like energy or total fat. Try energy, 53 calories per cake and 427 calories per 100 grams. So mass per cake is approximately 53 over 427 times 100 becomes 12.4 grams. Then 300 divided by 12.4, about 24 cakes. Cross-check with fat, 2.2 grams per cake versus 17.6 grams per 100 gram gives mass, approximately 2.2 over 17.6 times 100. 100 is 12.5 grams. Again, 300 divided by 12.5 becomes 24. And saturates 0.6 versus 5.0 gives 0.6 over 5.0 times 100 equals 12 grams, which still points to roughly 24.25. Rounding will push it to 24. So the salt method was a trap caused by rounding a small number. Using energy fat, which are less sensitive to rounding, we get 24 oatcakes in 300 grams. Answer D, 24. All right. Question 32. We were told 5 particular squares out of a 4x4 should be shaded. One student did it correctly. The other 4 each made exactly one mistake. So my first thought is, each student's sheet has 5 shaded squares, and the 4 incorrect sheets each differ from the true sheet in exactly one square. That means across the 4 wrong sheets, there are exactly 4 single square errors in total. A neat shortcut follows. Look at each cell over all 5 sheets and count how many times it is shaded. If a cell is shaded in the correct sheet, it will appear shaded in at least 3 of the 5 sheets. The correct student plus at least 2 others could also have it right, or up to all 5. If a cell is unshaded in the correct sheet, it can be shaded in at most 2 of the 5, since there are only 2 incorrect extra shadings available overall. So the true 5 shaded squares are exactly those cells shaded in 3 or more of the 5 options. So I scan the 5 small grids and tally visually. Immediately, the top row, third from left cell, is shaded in almost every option. That screams definitely shaded in the correct sheet. A couple more cells, the left cell of row 2, the right cell of row 2, the lower middle right cluster, also appear shaded in at least 3 of the 5 drawings. If I mark the cells that show up in 3+ grids, I end up with 5 cells that match option E. I did hesitate initially. Options A and B share many of the same shaded cells and look tempting. But checking counts cell by cell, the majority rule, shaded in greater than or equal to 3 of 5, rules them out. When I apply that consistency check, the pattern that remains is exactly the one shown in E. Final answer, E, because its shaded squares are precisely the 5 cells that are shaded in at least 3 of the 5 students' sheets, matching the requirement that the other 4 sheets each contain exactly one single square mistake. All right, question 33. We've got an advisor arguing that limiting family size, specifically through contraception, should be central to tackling global warming because more people means more lifetime carbon emissions. So the question is, what would most strengthen that? What I'm looking for is a fact that directly supports the proposed mechanism, that contraception-led policies could credibly reduce births and therefore emissions. The best support would be evidence that a sizable share of births are not actively intended, because that makes the policy lever both relevant and effective. Option C says many babies are born to people who didn't intend or wish to become parents. That dovetails perfectly. It implies there's a tractable pool of unintended births that contraception could prevent, thus curbing population growth and its carbon impact. That directly buttresses the advisor's conclusion about putting contraception at the heart of policy. So, my answer is C, because it strengthens both the practicality and impact of the recommended policy. Alright, question 34. We're told TV harms family communication because, rather than talking together as in the past, families sit and watch, becoming passive and content to be entertained. Then, with a consequently, the author leaps to television dampens people's ability to think for themselves. The key move to notice is the shift in what's being concluded. The initial claim concerns family communication. The final, stated conclusion is about people's general ability to think for themselves. The reasons offered, watching rather than discussing, passivity, being entertained, may speak to less conversation at home, but they don't actually establish a reduction in the ability to think. At best, they show a change in behavior during TV time, not a demonstrated impact on cognitive capacity. That's a relevance problem to the stated conclusion. Let me quickly clear the distractors. A. There's no contradiction between the opening claim and the final conclusion. The problem is a shift, not a clash. C. No single anecdote is used. It's not a one-case-to-all generalization. D. It mentions the past, but it doesn't argue past practice is right, so not an appeal to tradition. E. Not circular. The conclusion isn't smuggled into the premises, it's rather overreached. So the flaw is that the reasons don't actually support the stated conclusion about thinking ability. That's option B. Final answer, B, because the premises about watching and passivity don't substantively support the conclusion that TV dampens people's ability to think for themselves. All right, question 35. The passage opens with a recommendation. We need to change science lessons so they give a correct view of modern science. Everything that follows serves as support. Examples of additional states of matter like plasma and liquid crystal. The striking claim that plasma makes up 99% of the universe, and the assertion that the traditional three-state picture misleads children. So the structure is straightforward, evidence that the current teaching is oversimplified and inaccurate, leading to a prescriptive conclusion that teaching should be updated. The final sentence, the traditional view is giving children a false view, is a supporting judgment, not the endpoint. The main conclusion is the initial recommendation, neatly captured by school science should be updated to reflect modern science. That's option E. Final answer, E. Because the passage's purpose is to argue for reform in teaching, supported by the examples.
Isn't he great? Arthur's your very own Oxbridge tutor, built by real tutors who've guided hundreds of applicants into Oxford and Cambridge. He doesn't just know what makes a good candidate, he knows what makes an exceptional one. You've already learned from him here. Imagine what happens when he's guiding you directly. Interview slots fill quickly before the season starts, so don't wait. Book your session now at arthurtutoring.co.uk.
All right, question 36. Fergus Castle. Ferries between mainland and island take 40 minutes each way, and there's a 5-minute turnaround at the end of each single journey. Ferries leave the mainland at 5:25 and 45 past each hour from 09:05, and leave the island at 15:35 and 55 from 09:15. We're asked the minimum number of boats. My first quick impression is the usual cycle trick. A boat's bare round trip is 40 plus 5 turnaround plus 40 plus 5 equals 90 minutes between successive departures from the same side. Departures on a side occur every 20 minutes, so 90 divided by 20 equals 4.5, so you'd need at least 5 boats. That's a good lower bound. But pause. I must check the timetable alignment. Boats can only leave at the scheduled times. So if a boat arrives a little early and finishes its 5-minute turnaround, it may have to wait for the next scheduled departure, lengthening its effective cycle. Let's test with a concrete example to avoid a trap. Take a boat leaving the mainland at 09:05. It arrives the island at 09:45. Turnaround 5 minutes, ready at 09:50. But island departures are at 15, 35, 55, so the boat cannot leave until 09:55. It then arrives back at the mainland at 10:35, turnaround to 10:40. But mainland departures are at 05, 25, 45, so it must wait until 10:45 to leave again. So this boat's cycle between mainland departures is from 09:05 to 10:45. That's 100 minutes, not 90. So the effective cycle is 100 minutes because of the 10-minute offset between the two ports' timetables. With departures every 20 minutes, 100 divided by 20 equals 5 boats exactly. Fewer than 5 is impossible because a boat can only repeat after 100 minutes, and there are 5 scheduled departures in any 100-minute window. Therefore, the minimum number is 5. Final answer, C, 5 boats. All right, question 37. We've a table of pupils and teachers by UK region in 2003. And we're asked for the lowest ratio of pupils per teacher. That is, pupils divided by teachers. Smaller is better, fewer pupils per teacher. Looking at this table, the options are Midlands, South, Wales, Scotland, and Northern Ireland. Quick warning to myself, don't be fooled by small totals. We care about the ratio, not the size of the region. Let's run brisk mental divisions. England Midlands, 1,613 pupils over 88 teachers. 88 times 18 is 1,584, a bit short, so about 18.3 pupils per teacher. England South, 2,160 over 121. 121 times 17 is 2,057, times 18 is 2,178, a tad high, so roughly 17.9. That's better, smaller than Midlands. Wales, 497 over 26. 26 times 19 is 494. Very close, so about 19.1. That's larger, worse. Scotland, 893 over 59. 59 times 15 is 885. Remainder 8, so about 15.1. That's notably lower. Northern Ireland, 341 over 21. 21 times 16 is 336. Remainder 5, so about 16.2. I initially might have guessed Northern Ireland because the numbers are small, but the ratio beats that instinct. The lowest figure we've seen is Scotland at about 15 pupils per teacher. So the region with the lowest pupils per teacher ratio is Scotland. Final answer, D, because 893 over 59 is approximately 15.1, lower than all the others listed. Why C is correct. Key observation. 2 identical tokens must fit together, one rotated 180 degrees to make a complete disk. So every feature on the edge of one token must meet a complementary feature on the other token after a half turn. Equivalently, if you walk around the token's rim, you must alternate between protrusion and indentation relative to the circular outline, because each protrusion of token A must meet an indentation of token B, and after rotating A by 180 degrees, those rules swap. Look at the jagged top edge of option C. Moving along that top edge, you find 2 adjacent corners that are the same type, both protruding inwards-outwards with respect to the circle, without an opposite feature between them. That breaks the required alternation. When you rotate an identical C token by 180 degrees and try to mate it with the original C token, those 2 like features would meet each other, protrusion to protrusion or indentation to indentation, rather than a protrusion meeting an indentation. The pieces would either overlap or leave a gap, and so cannot form a perfect disk. By contrast, The other shapes, A, B, D, E, have their bumps and notches arranged so that after a 180-degree rotation, every bump on one piece meets a notch on the other. They satisfy the necessary alternation and can therefore be twins that form a disc. Hence, C is the one that cannot be a token used by the club. The passage reports a specific scheme that assigns an individual caseworker to the most vulnerable homeless people, describes what the caseworker does, helps them navigate health, justice, and housing systems until their life improves, and gives a concrete outcome, an average saving of £1,000 per month per homeless person that would otherwise have been spent on emergency support. From these facts, we can reasonably infer a policy recommendation that individual caseworkers should be assigned to homeless people. Why this follows? The passage presents the assignment of caseworkers as the operative intervention and gives two forms of positive consequence: improved lives and substantial cost savings. Those are the typical criteria for recommending a practice. It works and it pays for itself. The conclusion in A, individual caseworkers should be assigned to homeless people, is precisely the actionable recommendation that these presented benefits justify. Thus, A is a supported, reasonable conclusion. Why the other options are weaker or not as directly supported? B, vulnerable homeless people are costing too much. This is a value judgment not established by the passage. The text only says emergency support would cost money, not that the homeless are costing too much. C, some systems are hard for homeless people to deal with. The passage implies difficulty by saying caseworkers help navigate systems, but that is an inference about the systems rather than the main supported policy conclusion. It is weaker than A. D, homeless people rely on emergency support at present. The passage indicates money would otherwise have been spent on emergency support, but it does not establish the general state of reliance for all homeless people. E, the lives of homeless people are improved when they can easily access support. The passage says lives improve when helped to navigate systems, but E adds easily access support, which is a rephrasing that introduces the word easily and generalizes beyond the specific scheme. Again, weaker than A as a policy conclusion, because the passage both documents beneficial effects and financial savings attributable to assigning individual caseworkers. The best supported conclusion is the recommendation that individual caseworkers should be assigned to homeless people. A. All right. Question 40. We've got an argument saying government alcohol advice has been framed as a daily maximum, but that framing implies drinking every day is fine. Newer research suggests the body needs more than a day to recover. Therefore, health advice shouldn't be so simple that it encourages unhealthy behavior. Better to give more complex messages than simple ones that mislead. What must be assumed for that to work? The key move is the final comparison, that complex messages are better than overly simple ones that backfire. For that to be true in a health promotion context, the complex messages have to actually function, i.e. be read and understood by the public. Otherwise, they might be useless or even misinterpreted. Let's test the options. A. The old research is no longer valid. Tempting, but the critique isn't primarily the old science is wrong. It's the daily framing misleads in light of new research. The argument about messaging doesn't need to declare the old research invalid. B. Drinking every day is common, not required. The point is about what the message implies, not about current habits. C. People always follow health advice. Far too strong. The argument only needs that messaging influences behavior, not perfect compliance. D. Government should revise advice on all health issues, way broader than the argument, which is specifically about alcohol and messaging simplicity. E. Complex health promotion messages will be read and understood. Yes, this underpins the claim that complex messages are better. If nobody understands them, they're hardly better at promoting health than simple but misleading ones. So E is the necessary assumption. All right, question 41. We've got an argument built on fossil evidence. Every 20 to 30 million years, there's a mass extinction, and then, within 5 to 10 million years, biodiversity bounces back, often surpassing the previous level because the dominant species' disappearance opens niches for others. From that, the author leaps to, whatever disasters humans cause, life will ultimately survive and even become richer. So, we want what most weakens that confidence. The move here is from natural, historically observed extinctions to whatever disasters we may wreak. That's a pretty sweeping generalization, and the obvious angle is human-caused catastrophes might be different in kind, not just degree. Let me scan the options. B. Problems dating fossils. Tempting at first. If we can't time the rebounds precisely, the pattern might be less robust. But imprecision about dates doesn't really dent the core claim that life rebounds. It just muddies the clock. So not a strong weaken. C. Technology preventing natural catastrophes. That's irrelevant, or even supportive of survival. It doesn't undercut the conclusion. D. Some species can withstand extreme change. If anything, that props up resilience, doesn't weaken. E. Species have died out due to climate change. That's entirely consistent with mass extinctions. The argument already acknowledges extinctions. No challenge to the rebound claim. A. The consequences of a global nuclear holocaust are not known. Yes, that strikes at the inference. If we don't know what a uniquely human, potentially planet-wide synthetic catastrophe would do, we're not entitled to claim that whatever we do, life will still flourish long-term. The uncertainty specifically about human-caused mega-disaster undermines the sweeping conclusion. So the best weakening is A. It blocks the generalization from natural history to all human-made disasters. My final answer is A, because it highlights that we can't assume human-caused catastrophes conform to past natural patterns. All right, question 42. Tibber the cat eats 2 wet sachets and 25 grams of dry food each day. We're comparing daily cost from the local shop versus an online distributor. First, the local shop. 1 box of 12 sachets is 12 pounds, so that's 1 pound per sachet. 2 per day is 2 pounds. For dry food, 400 grams for 4 pounds means 1p per gram, so 25 grams costs 25p. Local daily total, 2 pounds 25p. Now the online deal. 4 boxes of 24 sachets cost 62 pounds 40. Let me do that in 2 steps. 62 pounds 40 over 4 boxes is 15 pounds 60 per box, and 15 pounds 60 over 24 sachets is 65p per sachet. 2 sachets per day, 1 pound 30. Dry food online is 2 kilograms for 16 pounds. That's 2,000 grams, so 1,600p over 2,000 equals 0.8p per gram. Multiply by 25 grams gives 20p, or 20 pounds. Add the online daily costs. 1 pound 30 plus 20 pounds equals 1 pound 50. Compare with 2 pounds 25 pounds locally. The saving is 2 pounds 25 minus 1 pound 50 equals 75 pounds, i.e. 75p. Quick sense check. Saving 70p on wet plus 5p on dry equals 75p. That matches. So the answer is B. All right, question 43. We've got 3 beasties. Arps with 6 legs, 3 horns, and a tail. Orps with 4 legs, 2 horns, no tail. And Erps with 3 legs, tail, no horns. Billy caught 45 creatures, yielding 222 legs, 99 horns, and 33 tails. We're asked, how many were Erps? Let's name them A, O, and U. Looking at this list of creature stats, the tails line is the friendliest because only ARPs and ERPs have tails. So tails give A plus U equals 33. Since the total creatures are 45, that instantly tells us O equals 45 minus 33 equals 12. Lovely. One variable down without algebraic sweat. Now horns involve only ARPs and ORPs. Horn's equation, 3A plus 2O equals 99. We already have O equals 12, so 3A plus 24 equals 99. Hence, 3A equals 75, so A equals 25. Given A plus U equals 33, we get U equals 33 minus 25 equals 8. That's my candidate. Quick sanity check with legs. 6A plus 4O plus 3U equals 6 times 25 plus 4 times 12 plus 3 times 8 equals 150 plus 48 plus 24 equals 222. Perfect match. So the number of ERPs is 8. The trick here was to spot that tails isolated A and U, immediately fixing O and making the rest a dawdle. Final answer, A. Net A cannot be folded to form the given L-shaped box because two faces that must be opposite, or at least not adjacent, in the finished box are placed adjacent in the net. So when you attempt to fold the net, the faces either overlap or leave a required face in the wrong position. A clear way to see this is to name the long horizontal strip in the net the base strip. The L-shaped box requires two vertical uprights at different positions along that base, and a top face sitting above one upright. In net A, the small square that would become the top of the tall upright is attached to the base strip in the position that makes it fold onto the same vertical wall as the short upright's top. In other words, the top face and one side face are joined in the net, where, in the 3D solid, they should be separated by another face. When you fold the dotted fold lines indicated in A, two faces attempt to occupy the same space. They clash, overlap, instead of forming the open corner of the L. No sequence of folds will reassign those faces to the correct relative positions, so the net is impossible to assemble into the required L-shaped box. By contrast, each of the other nets places the relevant top and side faces so that they fold into the correct relative arrangement without overlapping. So only A is impossible. Alright, question 45. We're being asked for the main conclusion of a short argument about buy-to-let and the London housing market. The key is to spot the author's overall point, not just a striking statistic or a prediction. Notice the flow. It starts with background, two objections in the 1990s, moral and practical. Then it observes what happened anyway. Buy-to-let grew. Consequence, housing became inaccessible for much of a generation. Supporting evidence. Rents rising 8 times faster than wages. Then comes a signpost. Plainly, no social good will come of this. That's classic conclusion language, plainly flagging the author's point. After that, we get predictions. Rents will continue to rise, and people's finances will become more precarious. Those read as consequences used to reinforce the main conclusion, not the main conclusion itself. Now, test the options. B is clearly a premise, the rents versus wages stat. D is one of the predictions at the end, likely a sub-conclusion. A and E are tempting paraphrases of earlier material. A narrows to London and asserts causation more strongly than the passage does. E restates the 1990s moral objection, but the author doesn't end on morality, rather on social outcomes. The one that matches the plainly sentence is C. No social good will come of buy-to-let. So, the best expression of the main conclusion is C.
Isn't he great? Arthur's your very own Oxbridge tutor, built by real tutors who've guided hundreds of applicants into Oxford and Cambridge. He doesn't just know what makes a good candidate. He knows what makes an exceptional one. You've already learned from him here. Imagine what happens when he's guiding you directly. Interview slots fill quickly before the season starts, so don't wait. Book your session now at arthurtutoring.co.uk.
All right, question 46. The core claim is, if either freedom of speech or freedom of assembly is present, then democracy inevitably results. The conclusion flips it. If you're under a dictatorship, you must lack both freedoms. That's a straight contrapositive of a disjunctive sufficient condition. A or B implies D. Therefore, not D implies neither A nor B. We want an option with exactly that form. Option B says, if heat or light is emitted, energy decreases. It follows that if energy remains constant, neither heat nor light was emitted. That's the same logical move. H or L equals decrease, not decrease equals neither H nor L. Perfect parallel. Briefly on the distractors. A goes the other way around. If both are lacking, then rejection follows, and it tries to infer both lacking from rejection. That's affirming the consequent. C gives a sufficient condition for eligibility, over 21 and degree/equivalent, and wrongly concludes ineligibility from its absence. Again, invalid. D introduces a disjunction, but then uses a different premise about liking to watch losing to force one side. Not the same structure. E muddles necessary and sufficient conditions for thriving, not our pattern. So the clean parallel is B. Final answer, B, because it mirrors the contrapositive of a disjunctive sufficient condition. The passage argues a utilitarian-style principle applied when every option is morally bad. Even if all actions are immoral, one should choose the course that brings about the greatest good for the greatest number, phrased here as eliminating the outsiders at the least possible cost and with the least possible delay. That is, when all choices are harmful, preference should be given to the choice that minimizes harm or maximizes net benefit to the population affected. Option B, the action that harms the least number of people is the best possible action, captures that principle directly. It states the rule of choosing the option that produces the least harm, which is equivalent to choosing the action that yields the greatest good for the greatest number when all options are bad. Why the other choices are inferior. A focuses on swiftness and cheapness as generally least immoral, but the passage's norm is about maximizing overall good, minimizing harm, not merely cost or speed in themselves. A also weakens the claim with often, which departs from the decisive principle in the passage. C, where all options are immoral, it is necessary to consider cost and speed, picks up part of the passage, cost and delay, but omits the essential aim, maximizing the greatest good or minimizing total harm, so it's incomplete. D and E recharacterize immorality, saying an action cannot be considered totally immoral if it is right or for the greater good. These miss the decisive comparative rule for choosing between immoral options. They reclassify morality rather than state the selection principle. Thus, B best matches the passage's principle. When all options are immoral, choose the one that inflicts the least harm, i.e., best serves the greatest good for the greatest number. All right, question 48. We've got a word game where each letter has a fixed value, and a word's score is the sum of its letters. I'm told the total scores for 4 words: tear, write, tree, and rat. I don't know any letter values at the start. How many letter values can I now deduce? I'll assign variables T, E, A, R, I for the letter values. The word totals give me 4 equations. Tear equals T plus E plus A plus R. Write equals R plus I plus T plus E. Tree equals T plus R plus 2E. Rat equals R plus A plus T. I don't know the actual numbers, but I can work with differences. First neat trick, Tear minus rat. That's T plus E plus A plus R minus T plus A plus R equals E. So E equals the difference between those two word scores. Lovely. E is nailed down. Next, tree minus rat. T plus R plus 2E minus T plus R plus A equals 2E minus A. Since I already have E, that lets me solve for A uniquely, as A equals 2E minus tree minus rat. So A is fixed as well. What about T and R? From rat, I know T plus R plus A, and with A known, I get T plus R. Tree also gives T plus R via T plus R equals tree minus 2E. A nice consistency check. But that's only the sum. It doesn't split T and R individually. Can I get I? Yes, from right, R plus I plus T plus E is known. Subtract E and subtract T plus R, which I've just found, and I pops out. I equals right minus E minus T plus R. So I is determined. So we can compute E, A, and I, but T and R remain intertwined. Only their sum is fixed. Therefore, exactly 3 letter values are calculable. Final answer, D, 3. All right. Question 49. 4 siblings in 4 time zones, each available 8 o'clock to 20 o'clock local. We want the total number of hours in a day when at least 3 can be on simultaneously. Let's put everything in London time. The offsets given: San Diego is 8 hours behind London. Barcelona is +1. Nairobi is +2. So their London time windows are: London, 8 o'clock to 20 o'clock. Barcelona, +1. 7 o'clock to 19 o'clock London time. Nairobi +2. 6 o'clock to 18 o'clock London time. San Diego, 16 o'clock to 4 o'clock London time. It wraps past midnight, 16 to 24 o'clock and 004. Now walk the day using the change points: 0, 4 o'clock, 6 o'clock, 8 o'clock, 16, 18, 19, 20. So 0 to 4 o'clock, only San Diego is on. Fewer than 3. 0 to 04. None. Nairobi only. Fewer than 3. 0 to 8 o'clock. Nairobi plus Barcelona. Still 2. 16 to 18. London joins, so Nairobi plus Barcelona plus London. 3 people for 8 hours. 16 to 18. San Diego joins as well. All 4 for 2 hours. Alright. 18 to 19. Nairobi drops, leaving London plus Barcelona plus San Diego, all 4 for 1 hour. 19 to 20. Barcelona drops, only 2. 20 to 24 o'clock, only San Diego remains, 1. Add the qualifying stretches. 8 hours, 08 to 16, plus 2 hours, 16 to 18, all 4 for 1 hour, equals 11 hours. So at least 3 are simultaneously available for 11 hours in each 24-hour cycle. That's option D. Each L-shaped table has an intrinsic color imbalance when you place a checkerboard over the floor. Because of the L's shape, it always covers more squares of one color than of the other. One color appears 1 square more than the other for that polyomino. 2 identical L's therefore always cover an area whose difference between the 2 colors is plus or minus 2. The imbalances add. Now look at arrangement D. If you lay the same checkerboard over that composite outline, you find the 2 colors occur in equal numbers. The raised central block sitting on the long base balances the coloring left and right. In other words, D has no color imbalance, whereas any shape made from 2 L's must have an imbalance of plus or minus 2. That contradiction shows D cannot be made from the 2 L-shaped tables. Every other drawing can be realized by a suitable rotation flip and edge-to-edge joining of the 2 L's. D is the only option whose parity coloring invariant rules it out.